Hey everyone, welcome back to the channel. Today, this video is going to be a final video in this series dedicated for SNI. In the previous few videos, I have discussed name-based virtual hosting, which allows multiple virtual web servers to share the same IP. Basically, a single machine hosts multiple websites in this case. We did some experiments using NSLOOKUP tool to show you how virtual servers shares the same IP. We used the example from the badssl.com for that purpose. You can refer to this video for more details on that. That's a really useful video. First, I talked about HTTP virtual hosting, and thanks to the host header to make this possible. Reason for thanks? Because it is this host header that transports the fully qualified domain name of the virtual web server the client wants to reach, or the client wants to connect, which on the other side helps web server to serve correct website or data depending on this host header. We used Postman tool to show you the role of the host header in action in virtual hosting, where for this host header was used to route the request to different websites. Second, we learned about HTTPS virtual hosting and SNI, where we learned about how HTTPS setup was failing with virtual hosting. Reason for this failure? Because in virtual hosting, the web server relies on host header to serve the correct data to the client depending on the domain name the client is trying to reach. But you know that in TLS setup, HTTPS encrypts the traffic and the host header in this case is encrypted. So there is no way for the web server to know what is the value of this host header. The web server cannot access this host header before finishing this TLS handshake. At the same time, for the TLS handshake to complete, the web server has to supply the correct website's certificate. So you see there is a deadlock situation here. Hence, SNI was introduced to solve this problem. SNI allows a client to specify the host name in the client hello message when TLS negotiation starts during the initial TLS handshake. This allows a server to present multiple certificates on a single IP address and to ultimately host multiple HTTPS site using different certificate on the same IP address. During the TLS handshake, server refers to the SNI value to present correct certificate for the appropriate virtual server. You can refer to this video in detail where I have shared about this in one of my previous video. Then in the third video and the last video, basically I shared with you all one of the API integration issue that I faced due to missing SNI in TLS handshake, and I talked about web server behavior when the client does not send SNI during the handshake. I used Qualys SSL Labs for that purpose. I used that Qualys SSL Lab tool to show you how the servers behave when SNI is sent in the handshake and when there is no SNI is sent in the handshake. Server sends two different certificates based on the absence of SNI and presence of SNI. Now you can refer to this video again at the top. I have provided the link here. Okay, so what we learned is that the SNI determines which certificate is presented by the server during the TLS handshake, basically for the HTTPS deployment, while the host header in the HTTP request determines which website content is actually served to the client.
Well, thanks for sharing those details, Gaurav. However, I have one doubt. If I configure HTTP client and set domain as domain 1, for example, expired.badssl.com in the connection URL, but then I explicitly set the host header value to some other domain too, like selfsign.badssl.com. In this case, what SNI TLS extension is set to, and where HTTP request is sent.
I'm glad that you have asked this question. In the situation that you described, where you set the domain you are trying to reach as expired.badssl.com, but manually add a different host header with the value self-signed.badssl.com. Let me explain. Here is what most likely would happen, and I'll demonstrate this using curl and OpenSSL tool as HTTP client. So let's go for the demo and let's see how this works. Okay, let's see how the SNI value is determined and set during the TLS handshake. Through our previous discussions, we have already established that the SNI value is set by the client during the initial TLS handshake based on the domain or the host name that the user tried to access. Right. So let's, for example, we take OpenSSL command is client connect. So let's see what happens when we issue this command in the terminal where the OpenSSL is trying to connect to the domain expired.badssl.com. As per what we just discussed now, the SNI value should be set to the value expired.badssl.com, and the server should present me the corresponding certificate for this domain. Okay. So if you see here, right, okay, you see here. So when we issue the command OpenSSL as client connect expired.badssl.com, the certificate that server sent to us is the wildcard certificate badssl.com, and then we see that certificate has expired already, not after 2015. So we received the appropriate certificate for expired.badssl.com where the certificate has expired, right? And it has a certificate chain. As you can see, the first certificate is this one, badssl.com, which is expired certificate, not valid after 2015, and then it has its own issuer, right? Now if you issue the same command for other domain, self-signed.badssl.com, so as what we just discussed, the SNI will be set to self-signed.badssl.com, and we will receive the certificate, self-signed certificate, not the chain of the certificates and expired certificate that we received for expired.badssl.com. Let's check it, what happens. It says here self-signed certificate. It is not the chain of certificate that server has returned. It is only one certificate that is installed there, and even the validity is also 2027. When we connected to expired.badssl.com, it was 2015, expiry was 2015. When we connected to self-signed.badssl.com, the expiry is 2017, and it is only one certificate. So this confirms our understanding that when we issue the command, the default behavior is that the domain name is the SNI, and then the corresponding, and then the server sends the corresponding server certificate for that domain. But we have also discussed that SNI determines which certificate is presented during the TLS handshake. So if there is a mechanism that we can do the custom SNI to show you what certificate is presented, let's see. Let's customize the SNI this time. Okay, so we will use this command. Okay, but in here we have one, in OpenSSL we have one option, that is server name, which sets the custom SNI, sorry, the command. So if you see here, I'm still trying to connect to self-signed.badssl.com, but this time I have configured additional custom server name expired.badssl.com. So what do you think will happen in this case? now you all guys are expert in SNI, so you should know that this time the certificate that server will present, it will not be for self-signed-badssl.com, but it will be for the server name expired-badssl.com. Let's confirm it. Okay, and here you go. As you can see here, we issued the command to connect to OpenSSL for self-signed-badssl.com, but we did the custom SNI server name, and then we received the chain of the certificates, root certificate, intermediate certificate, and then the leave certificate, which is expired, again, which is not valid after 2015, right? So, and if you just reverse the command, then also you can just reverse the command. So we will write here self-signed-badssl.com, and here we will change this to expired-badssl.com. Okay, so now tell me which certificate will be presented during the TLS handshake. It will be for the self-signed-badssl.com, not expired-badssl.com. Let's confirm it. Okay, oh, here you go again. See, it is only one certificate, and that too is expiring in 2027, right? So it is SNI reconfirming and sharing with you again that it is SNI which determines which certificate is presented by the server during the TLS handshake. Let's see what happens using curl command. Okay, so I'm just first showing you, because I'm yet to answer the query that was asked to me in this video. So, but before I go to answer that one, I just want to establish some, the background. So let's see what happens when you issue the command badssl.com. So this is simple curl command to expired-badssl.com that will give me the website content for expired-badssl.com, and if you see, it is okay, and the document that has been returned from the expired-badssl.com is, you can see here, the title is expired-badssl.com. So curl is looking at the domain that we have typed here, and it tells the host name right at the beginning of the TLS handshake, and this allows the server to present the correct content. It will be the same thing for self-signed. This time you will receive the title self-signed-badssl.com, right? But this command that we just issued, curl command to self-signed and curl command to expired-badssl.com, this just shows that the request is going to expired-badssl.com and request is going to self-signed-badssl.com, right? But it doesn't say which certificate is being presented during the TLS handshake. So what we need to do is just add some verbose information to this, and now you can see that the certificate that is presented during the TLS handshake is for the appropriate domain. That is, in this case, it is for self-signed-badssl.com, and that is expiring in 2027, and it also gives you the content self-signed-badssl.com, right? If you again just issue the command to expired-badssl.com in the verbose, what will happen? The HTTP client, which is curl in this case, will set the host name during the initial TLS handshake. The server will see the SNI that it is for expired-badssl.com, and it will give the content expired-badssl.com, and it will also give me the certificate, which is nothing but an expired certificate. As you can see here, it expired already in 2015, right? So we saw in OpenSSL, and we confirmed in curl also, that by default the behavior is it looks at the hostname that you have typed, and that hostname is set to the SNI during the TLS handshake, and then the server sees this SNI and presents the corresponding certificate to the client, right? Now let's see the role of host header in this case, and slowly that will answer the query that was asked in this video. I will just use the same information, right? But I will add additional custom header in this case, right? So I will just post host. Okay, so what I have done here is that I am sending a curl command to badssl.com, but then I have add additional host header here. So what do you think will happen in this case? First issue the command and then we'll explain like what happens in that case, right? So this is the query I think that was asked in this video, right? Let's see. Okay, so what we just saw is, if you see the title is coming to self-sign badssl.com. It means that the request is served from the badssl.com, and that's what this host header is there for. If you remember in the last video, we had discussed that it is after the TLS handshake is complete, and once the secure connection is established, then the HTTP client sends the HTTP request to the server with the host information, in this case self-signed badssl.com, and then web server upon receiving this HTTP request looks at the host header to determine that request is for self-signed badssl.com, and it serves the content from that website. Okay, but if you have not noticed what happened to the TLS handshake, what certificate was presented during the TLS handshake, right? So as per our understanding, we just saw in the previous video that it is this what you type here determines the default behavior of the SNI is set to that value. So let's see, did we receive the certificate for expired badssl.com? Let's confirm it, right? Because it is saying that connected to badssl.com. So it means that when we shoot the command and to answer the query, what would happen when the domain is set to expired badssl.com, but we manually add a host header point to self-signed badssl.com. In this case, what happens is curl command is issued to expired badssl.com. The SSL handshake happens, as you can see here, the client hello, server hello, and everything. And during the TLS handshake, as per the default behavior, SNI is set to expired badssl.com. TLS handshake completes with badssl.com, as you can see here, that certificate expiring in 2015. So server sees the SNI that the SNI value is expired badssl.com. It gives us that certificate, and TLS handshake is completed with expired badssl.com certificate. But once the TLS handshake is complete, then the client sends the HTTP request for self-signed badssl.com. As you can see here, this is the GET request issued by the client to the server, and uses the host header this, and then the server sees that, oh, you want to connect to the self-signed badssl.com, and then it gives us the data from the self-signed badssl.com. Isn't this magic? Actually, it's not the magic, it's the culmination of all the effort that you put in all the last 4 videos to understand the SNI and SNI role during the TLS handshake, but the application data is still served and based on the host header that is passed from here. So I hope that this would have helped you to understand and answer the query that was asked in this video. But before we close this video and finish this video, I want to share one more thing. Like in the last video, we had discussed that when client doesn't send the SNI, then server was sending the default server certificate. That is possible because the SNI extension is designed to be the backward compatible. This means that if the server does not recognize the SNI extension or doesn't see the SNI value in the client hello message, the server still continue to do the TLS handshake, which is the default certificate that is deployed on the server as a fallback mechanism, right? So if you just see here, right, I issue the command to connect to expired badssl.com 443, and I just issue some random domain, right? So what happens in this case? We have already seen that if there is no SNI, the server sends the default certificate. Now, when you put any random SNI also, which server doesn't understand, server will send the default certificate, as you can see from here, right? We sent expired@ssl.com, but we set the custom server name 2222.com, which doesn't even exist, right? But if you see, after we typed in this command, the domain name resolution was done to resolve this domain expired@ssl.com to the IP. And once the client connected to the IP, during the client hello message, it sent this server name 222.com, but server couldn't understand what is this domain. In that case, server responded with a fallback certificate, as you can see here, bad SSL fallback, unknown domain, or no SNI. So you see the beauty that sits at the intersection of the domain resolution, where the whatever the domain that you are trying to connect is still used to resolve domain to the IP of the server. Once this is done, in the client hello message of the TLS handshake, the server name was set to 222.com. Server looks at this SNI, doesn't know what the heck is this, and then it sends the fallback certificate. That's what the SNI is designed to be, because it is designed to be backward compatible. It still has to do the TLS handshake, and once the TLS handshake is done, then it looks at the host header to send you the appropriate content for that website. Okay, we reached the end of the video, and with this, the end of this series. I hope this would have helped you to understand and appreciate the concept better. Okay, this brings us to the end of the video, and along with that, end of the video series on SNI. I'm sure these videos would have helped you in your understanding of SNI. That's it for today. You can subscribe to watch more such videos on my YouTube channel. Thank you so much. I'll see you in the next videos.